Welcome to Mitsubishi Electric's Nagoya Works Shinshiro factory. Today, we'll show you our production process for three-phase motors, which work to power many different kinds of machines. Shinshiro Factory was established in 1974 as a branch factory for the Nagoya Works. Since then, the factory has produced a wide range of motor products that combine state-of-the-art mechatronics and system technologies. Our high-quality, highly efficient, and functional manufacturing has made high-mix, low-volume production possible by integrating tradition with the most advanced techniques. Now let's take a look at the Made in Japan quality construction that leverages our proprietary steel frame technology, along with the latest development of products that globally comply with motor efficiency regulations. A long line of motors tells the story of Mitsubishi Electric's history. This is the model MK motor that Nagoya Works produced about a century ago. The spirit of craftsmanship and solid technical capabilities established at our founding continue. The Shinshiro factory has set up an integrated system for three-phase motors, covering from component manufacturing to assembly. A three-phase motor consists of three parts: a frame, which is the outer case of the motor, a stator, or the winding that generates rotational force, and a rotor, which is the part that actually rotates. These are assembled to produce a completed motor. Well then, let's take a look at each manufacturing process. There are three types of motor frames: steel frames, cast frames, and aluminum frames. The Shinshiro factory produces steel frames as our core product. Now let's take a look at the frame manufacturing process. The frame production distills Mitsubishi Electric's original steel frame technologies. A flat steel sheet is rolled into a cylindrical shape. This will be formed as the motor's exterior. First, a thin, flat steel is curved by a rolling machine into a cylindrical shape. The rolled steel sheet is shaped with a press machine and finished by applying a vertical joint welding to weld the two ends together. Robots are used to automatically weld heat sink fins and other mountings to the cylindrical frame. The sizing process expands the interior of the frame to a uniform diameter. And after finish processing to remove any spatter from the welding, the frame is given an undercoat with electrodeposition coating to prevent rust. Next, let's look at the process of manufacturing the stator, which generates the force that turns the rotor. To produce motor stator cores, a large press machine is used to punch out core pieces from the hoop of thin metal sheet. The pieces are layered to form a solid one in specified thickness. The layered pieces are given a half turn to make a straight stack in an appropriate size, and the two stacks are pressed to form a block in a process called rolling and stacking. A series of detailed steps support the foundation of our safe and high-quality manufacturing. First, a steel core is punched out from the hoop material, which is wrapped like a large piece of cellophane tape, with a large press machine that can handle the Japanese largest class punching load of 400 tons. There are three ways to integrate the iron core: welding method, punching caulking method that uses a large mold to caulk in a press machine, and strap caulking method that fixes by driving a wedge around the core periphery. Stator cores for medium capacity motors are formed using this strap caulking method. In strap caulking, the wedging strips are hammered into slots in the outer surface and then flattened with rollers, and the core is held. Next, winding proceeds with the insertion of copper wire coils into the grooves of the integrated core. The winding process can be roughly divided into two types: machine winding and hand winding. For processes in manufacturing special products that cannot be automated with machines, professional skills are used in producing and inspecting each piece by hand. It exhibits the craftsmanship unique to Mitsubishi Electric, a company with a long history in manufacturing motors. The machine processing starts with rapid winding of the coil, one pole at a time, to form a concentric winding. One coil is formed for each pole. To prevent direct contact between coil and core, slot cell insulation is first inserted into the slots. The coil inserter then automatically inserts the coil into the stator. On the machine winding line, jigs differ depending on the size of the motor frame and whether the motor has 2, 4, or 6 poles. According to the winding line, the model to be produced, the motor frame number, and the number of poles will vary. In hand winding, the coils are wound around a wooden frame and then inserted in the stator core. In the connection stage, the copper wires are inserted into plastic tubes to distinguish the U-phase, V-phase, and W-phase windings. Bundling the windings, shaping, and other processes are also performed carefully by hand, one motor at a time. Next comes the process of assembling the frames and stators that comprise the motors. In this process, the stator is pressed into the frame using a hydraulic press. By this stage, the motor bases are almost formed. With the coils inserted, the stators are varnished to fully bind the copper wire coils. The varnished stators are press-fitted into the undercoated frames with a press machine. The flanged rim used to attach the lid to the frame is then formed. After that, the height of the frame is precisely adjusted with the base relative to the rim. Next, let's take a look at the process of manufacturing the rotor, inside of which the shaft rotates. In the process of producing the rotor, which is the core of the motor, a machined motor shaft is inserted into the cast aluminum rotor core. A key point is to have the shaft fit the core so precisely that no gap is left between them. In motor shaft processing lines for many special products, the grinding process used to require much time. We introduced the e-factory system that visualizes the factory's processes to shorten the time required in grinding and enhance precision further. In manufacturing each shaft, a steel rod about 5 meters long is cut to the specified length. Centering involves drilling the center holes that serve as the reference for processing. The workpieces are rotated about the center hole on a lathe, with a cutting tool used to shave away the shaft's outer circumference, followed by keyway machining, where a machining center is used to cut the grooves. For these processes, we have adopted a grindingless system that feeds back tool wear data and other information to previous processes beforehand. This allows us to measure dimensions and make corrections while automatic operation is in progress, reducing the time required for machining motor shafts by 15% and improving productivity by 30%. Ball sections containing ball bearings are processed with a grinder, which indicates the dimensions with the rotating circular grindstone against the rotating shaft. The rotor core, which is the core of the motor, is manufactured from die-cast molten aluminum. With the die casting machine, molten aluminum heated in a blast furnace to temperatures of over 700 degrees is poured into the shaft and exterior grooves to form the rotor core. Burnishing is used to adjust the inner diameter to the specified size. After smoothing out any surface unevenness, the workpiece undergoes shrink fitting to set the rotor core and shaft. The rotor cores are placed in a heating furnace and heated to over 300 degrees. The finished shaft is inserted in the space gap in the interior of the rotor core that is created by thermal expansion. Although the shaft's diameter is designed to be greater than the inner diameter of the rotor core, the shaft can be inserted by applying heat to expand it. The shrink-fitting process incorporates the technologies and experience that Mitsubishi Electric has developed over many years. Leveraging a wealth of data and master techniques, we adjust the heating to achieve the optimal temperature for the rotor core's material and model. Through the steps of cooling, truing, then reducing the outer diameter on a lathe, the rotors are balanced on a balancing machine, and a rust-preventative coating is applied to the unit. Well then, now let's look at the final assembly of the frame, stator, and rotor. With the rotor put together with the press-fitted stator components, assembly of the motor is complete. Each finished product undergoes an electrical test and visual inspection before being shipped to customers in Japan and overseas. Here are various types of motors that have passed inspection. Two of the Shinshiro factory's three-phase motor assembly lines are used for assembling medium-capacity motors. With 4 smaller assembly lines used for low-capacity motors, the factory has a total of 6 lines in operation. The motors for a wide variety of applications, which support multi-item small lot production, are shipped from here to customers throughout the world. We hope you enjoyed this description of our 3-phase motor production process. Mitsubishi Electric's Nagoya Works Shinshiro factory, equipped with state-of-the-art equipment, has developed a multi-item small lot production line that produces high-quality products with short delivery times. While introducing eFactory, promoted by Mitsubishi Electric, we maintain our commitment to domestic production and made-in-Japan quality in our integrated production of 3-phase motors from components to assembly. Mitsubishi Electric continues to promote further evolution of the various kinds of technical expertise we have developed thus far, as we pursue the potential of clean, highly efficient, energy-saving motors that meet the demands of the day to help bring about a more prosperous world. Changes for the better represents the Mitsubishi Electric Group's attitude to always strive to achieve something better as we continue to change and grow. Please keep an eye on Mitsubishi Electric's Nagoya Works Shinshiro factory as we continue opening the door to a new future through the fusion of century-old tradition and the latest technology.